Okay, good morning. I want to go over this example number 5 from the Savas program today. And this talks about how to do a quadratic regression. Now, the previous example, example number 4, talked about using points to create a quadratic equation. And they were doing a process using matrices. And we haven't talked about how to use matrices yet. So for right now, matrices is a more advanced way to solve a systems of equation. And in that situation, they gave you 3 points and you wrote out 3 equations and set up a matrix and use that to solve it. We're going to use quadratic regression, and we're going to use Desmos to do this. You can also do this in a TI-84, and I imagine a number of other tools that you can use to do this. So here is the situation. Discus thrower. They recorded the height, recorded the X and Y coordinates of the throw of a discus. Okay, so points show the horizontal discus, the distance the discus traveled in meters, and the height of the discus in meters. So at 1 meter is a height of 1.75, at 2 meters is a 2.71. So we're going to find the equation that describes this motion, and we're going to create an equation model for this throw. So we're going to go to Desmos, and under Desmos, I'm at the home screen here. We're going to click the plus button, and we are going to add an XY table. Okay, so we're going to start by adding these points, and we can see that the X values go from 1 through 10. So I'm going to add those first. And next we got to add our Y values. I have them written down here separately, and I advise you to do that because then you don't have to switch back and forth between tabs. So you need to put these in. 1.75, 2.71, 3.52, 4.28, 5.45. You can see the points are showing up here on the graph as I'm typing them in. 6.12, 6.29. I want to double check that one and make sure I wrote that. 6.79, very important that we get them accurate. 6.79, 7.34, 7.99, and 8.55. And you always want to go back anytime you input data into any technology tool. It is of utmost importance that you double check that you have input it properly, because if you did not, you cannot get the correct answer. You can go through all the steps correctly and get the wrong answer because you forgot a decimal place or had the wrong number in here. One of the nice things here, once we've input our data, most of these show up pretty easily for us here. But that's not always the case when you input a data list. So there is a button here that says Zoom Fit, and it will fit the window to your data points. Okay. So the next thing we want to do is we're going to do a quadratic regression. We're expecting this to be a quadratic equation. There are other regressions you could do. You could do a linear regression and fit a line to this as well. We know we're looking for a quadratic in this case, so we're going to do that. And the way we're going to do that is we're going to write an equation using y1 and x1 as our variables. So I will start by typing y1, and you will see that it will automatically put it in there as a subscript. And because this data isn't a perfect quadratic, it's an approximate, to the left of the number 1 on your keyboard is a little squiggly line. There it is. That's telling it that we are looking for an approximation. And now we're going to type in the standard form of our quadratic equation. So I will type in a x1 squared plus b x1 plus c. And you will see that it has created a quadratic parabola equation to match as best as it can to our data. And you can see these aren't perfect. They never will be. If we look down here, if I could scroll down, Desmos has given us what our A, B, and C values would need to be for a quadratic equation to match this data as accurately as possible. They also give you this here. this r squared, this is a measure of how accurately the data points and the equation model match each other. We're at 0.9982. That's a pretty good match. So very simple to do a quadratic regression. All we would do now is we would write down our equation. Y is equal to negative 0.027 x squared plus 1.05828 x plus 0.672167. So you're literally just substituting the a, b, and c values into your standard form of your quadratic equation. So that's how you would create a quadratic model or quadratic regression from a list of data points, and go ahead and use that for the rest of the examples and the problems you're assigned.